Okay, so for this video, it's just going to be part B of the previous video. So if you didn't see that, you should watch that one first. So for the first one, we kind of did the projection. We found the projection of two vectors. So that's going to be this top one here. And so now what we want to do is we want to solve for vector q, which is a third vector that we're introducing, such that the magnitude of q is equal to the distance from p. So they give us this point here, and those are the coordinates for it, to the line given by the vector equation. So this is a vector equation here. So remember, so this is p, t, and then this is d for distance, okay? So we have, again, so this is just kind of another way of doing, so this is the kind of the x coordinate, this is the y coordinate, this is the z coordinate. So we're working in x, y, and z, you know, instead of before we were kind of doing the vector components I, j, and k, but same idea. So it's in 3D, it's a vector. So first kind of thing that I like to do, so I don't know how to do the fancy L, so I'm just going to do it like this. So LT is equal to P, so is equal to this, plus TD, and D is the distance here. And then I like to just write it out over here so that I kind of don't have to scroll back up. So P is equal to, oh, sorry, this is little p. So this is why sometimes you can get confused. So 0, 3, and 1. So that's going to be this. Okay, and then distance is going to be 2, 0, and this actually should be -1. I just didn't copy it down correctly. Okay. So first step, you want to build the vector from the line point to your point. So what we have here, so we want to write out PQ, Q minus P. So the distance between them is what this means, right? So that's going to be equal to 3 minus 0 minus 2 minus 3 and 3 minus 1. Okay, and so again, so this is Q. We have our Q. We have our distance, and then we had our P up here. So we're gonna get 3. That's gonna be so -5 and 2. Like that. It's part of my writing. Okay, and then so when we plug in our projection now, so that's where this guy here comes in. We want to write this out as P. So I'm just gonna write second step. P R is the projection of D, and then so of PQ onto D. So this will be, so projection D PQ to PQ D, and same formula as before. So this is just the projection formula, only we're doing D now instead of before we did V, right? Okay, and then this is times D as well, or dot D, sorry. So now we just compute the dot products. So P and Q dot D is equal to 3, -5, 2, dot 2, 0, -1. Okay, so that's gonna give you, so 3.2 plus -5.0 plus 2 dot -1. So that'll give you 6 plus 0, because this is 0, this is 6, and that'll give you -2. 4. Okay, and then so we have d dot d. So that's the denominator now that we're doing. 2, 0, -1 dot 2, 0, -1. And so that'll give you 4 plus 0 plus 1, which is 5. And so now we have 4/5, because this is the denominator, or sorry, the numerator, and then this is the denominator. So I guess we could write it out as like the entire thing now. So PR equals 4/5D equals 4/5 2, 0, -1. And then so that's going to give you 8/5 0 and negative. So we distribute that negative to the whole thing, 4/5. So this whole thing here will be your PR, so your R minus P. And then we want to define this as a function, I guess, of Q. So now that we have our RQ, we can do PQ minus projection of D, PQ, and then we just compute that. So Q is going to be 3, -5, and 2, minus 8/5, right? 0 and -4/5. And then, so what we do is we distribute. So 3, so this is 3 minus 8/5. And then -5 minus 0. So I'm just going to do it like that. And then 2 plus 4/5. Okay, and then so that should give you so 7/5 minus 5 and 14/5. Okay, so that's the last step there. So that's the vector that we were trying to find, the vector Q. And then sometimes what they like to do is they have it, so that's the magnitude equals the distance from the point to the line. And they kind of, sometimes they, like, professors will want it written like with that kind of greater than sign or whatever. I don't really know what it's called, but they want it like that. And then you just kind of write it like that if you want to be like super technical, but I'm sure no one like I don't know. I would probably just submit it like that, but it's up to you. You could do a quick check as well. So once you get this final answer, what you can do is, so Q should be orthogonal to the line direction D, which all that means, it's just fancy language. All that means is that if you subtract it, it should equal 0, okay? So what you do is you do your Q dot D, your distance, and so you take your 7/5, -5, and 14/5. And you do that dot 2, 0, -1. Okay, and then again, just components together, 14/5 plus 0, and then negative. And then you just distribute the negative like that over 5. And then if you add all that up, so you can ignore that middle term, 14 minus 14, and then that gives you 0. 0 means it's orthogonal. So that is kind of just a quick way to justify or to check if your answer is correct. If it gives you anything other than 0, usually it's like an arithmetic error, like you maybe didn't subtract properly or multiply properly or something like that, and then you just kind of have to go back and see where you went wrong. So thank you. Hope this helped out, and yeah.